Hi everyone. Today we are going to discuss about the linear algebra concepts. In linear algebra, we are going to discuss about linear transformation. So, what is the meaning of linear transformation is, so let T from V to W is said to be a linear, So, when you have say this T is said to be a linear, the vector space, one vector space to another vector space. So, this is a V vector space and this is the W vector space. The transformation from one vector space to another vector space by the function T. So, that is representation of T from V to W such that the following condition should be satisfied. What is the condition is T of alpha U plus beta V equal to alpha into T of U plus beta into T of V. So, this is the main condition of linear transformation. So, T of alpha U plus beta V is nothing but, so just apply T to each term. So, you have to take the scalar outside. So, alpha into T of U plus beta into T of V. If the condition satisfied, then you can say it is said to be a linear. So, some of the basic terminology we have to know. Number 1 is rank. Number 2 is nullity. So, this is the basic terminology of the linear transformation. What is the meaning of rank? Rank is nothing but dimension of R of T. So, rank is nothing but dimension of R of T. Similarly, what is nullity is dimension of N of T. So, rank is nothing but dimension of R of T and nullity is nothing but dimension of N of T. Then what is R of T and what is N of T? So, R of T is nothing but range space. So, R of T is nothing but range space. What is the meaning of range space is set of all T of U such that U belongs to capital V. So, this is the definition of range. What is the meaning of range is nothing but range is representation of the R of T is set of all T of U such that U belongs to V. Nothing but, see, we are taking one element U from the vector space V. So, this U is transformed to the another vector space by the function T is nothing but the image is T of U. So, the set of all elements in W is called range. So, range is nothing but what are the elements have the pre-image of the set W is called the range. So, range is nothing but T of U such that U belongs to capital V. So, the collection of range that is called dimension, that is rank. So, collection of range is called rank. So, rank is nothing but dimension of R of T. What is R of T is nothing but collection of the codomain who has the pre-image of the domain. So, T of U such that U belongs to capital V. So, this is called range. And similarly, what is nullity? Nullity is nothing but dimension of N of T. What is N of T is nothing but null space. So, N of T is null space. What is null space is U belongs to V such that T of U equal to 0. So, this is the definition of null space. What is the meaning of null space is, see, you are collecting, so U, V, W. So, all the elements of the domain V is mapped to one element of the codomain that is called the 0. The identity element of the another vector space we have to map, that is called null space. So, null space is nothing but set of all elements. You have to take the elements from the vector space V that mapped of T of U is mapped to be a 0. So, that is called null space. So, the collection of null space is called nullity. So, this 2 is very, very important terminology in linear transformation. Number 1 is rank and number 2 is nullity. Rank is nothing but dimension of R of T. Nullity is nothing but dimension of N of T. So, Using rank and nullity, there is a specific theorem is called dimension theorem. So what is the meaning of dimension theorem is, so dimension theorem is using rank and nullity, there is a theorem is called dimension theorem. Rank of T plus nullity of T is equal to dimension V. So this is a dimension theorem statement. So rank plus nullity is equal to dimension of the vector space V. So domain vector space V. So this is the dimension theorem statement. So if you know the rank, then easily you can able to find the nullity. If you know nullity, you can easily able to find the rank. So this theorem plays a vital role in linear transformation. Rank plus nullity equal to dim V. So some of the basic results you have to know. So for that, note number 1, T is 1 to 1 if and only if nullity equal to 0. If you say the nullity value is 0, then you can say T is 1 to 1. This is the main note of the linear transformation. And number 2, T is said to be onto if rank equal to dimension W. So this is a 2 important note you have to know. So number 1, you can see T is a linear transformation, all the conditions are satisfied, and you can say T is said to be 1 to 1 if and only if nullity equal to 0. If the nullity value is 0, you can directly say the linear transformation T is 1 to 1. So this is a simple note, you have to know it. And what is the second note is, T is said to be onto, already T is linear transformation, it satisfies the linear transformation, and T is said to be an onto if rank equal to dimension W. See, rank value and dimension of the vector space W, codomain vector space dimension is equal to the rank, then you can say T is onto. So this is the basic terminology and important note you have to be done. In summarize, I'll just summarize the basic concept of linear transformation. So linear transformation is nothing but the transforming from one vector space to another vector space such that this condition should be satisfied. What is the condition is, T of alpha u plus beta v equal to alpha into T of u plus beta into T of v. This is the main condition. The transformation is linear. And the basic terminology of the linear transformation is rank. Rank is nothing but dimension of R of T, and nullity is nothing but dimension of N of T. So this is the basic terminology of the linear transformation, and R of T is nothing but range space, and N of T is nothing but null space. After that, the note is, when you can say T is said to be an 1 to 1 is if and only if the nullity value is 0, then you can say T is 1 to 1. If rank and dimension of the another vector space W is equal, you can say T is onto. So this is the basic ideas of linear transformation. Then we move on to the problem to understand the concept of linear transformation. This is a very important problem regarding linear transformation using dimension theorem concept. So the question is, T from R square to R cube is linear, and so they already given what is the domain is R square. This is the one vector space to the another vector space is R cube. What is R square? It is a ordered pair. So the elements from R square is ordered pair x comma y, and is mapped to the another vector space R cube. R cube is nothing but triplets x comma y comma z. So is linear, and given that T of 1 comma 1 is 1 0 2, T of 2 comma 3 is 1 minus 1 4. So this is the value is given in your data. So T of 1 comma 1 is 1 comma 0 comma 2, T of 2 comma 3 is 1 comma minus 1 comma 4. See, T of this value is belongs to the first vector space. So R square. The image, the resultant value is belongs to R cube. See the triplets value. So this is the meaning of one vector space to another vector space transformation. So T of the vector space V is mapped to the image as another vector space R cube. So similarly 2 comma 3 belongs to R square. The image of that under T transformation is 1 comma minus 1 comma 4 is belongs to the another vector space R cube. So this is the data is given. From this data you have to find out T. Next any value. So you can find out 4 comma 5 or anything else, any numbers from the ordered pair. So next number third, how to find rank, and we have to check T is 1 to 1, T is on to. So these are the standard questions you have to know. So this is the question. So given data is T from R square to R cube is linear and the sum of the basic value is given. From the value you have to find out what is T and the subdivision of this rank. T is 1 to 1 onto. We have to check all the subdivisions. So solution. So solution is very easy. Before entering into the solution, we have to know what is the standard basis of the R square. So R square is a one vector space. We have to take the standard basis element of the R square. So R square standard basis is 1 comma 0, 0 comma 1. This is the standard basis of R square. Suppose if the vector space R cube to R square, now you have to take the standard basis of the domain part, not the codomain part. You have to take the standard basis of domain. So domain is R square. So R square value is 1 comma 0, 0 comma 1. Suppose the question is T from R cube to R square. So domain is R cube. You have to pick the standard basis element from the domain part. So R cube standard basis is 1 0 0 0 1 0 0 0 1. So depends upon the domain, we have to take the standard basis. So standard basis of R square is 1 comma 0, 0 comma 1. So I am just taking the general element of the R square. So x comma y belongs to R square. So R square is belongs to the ordered pair. I am taking the general element from the ordered pair is x comma y. So now our aim is to separate, see, x comma y should be written in the form of the standard basis format. So we have to take x outside. If you take the first value outside, automatically it becomes the second value is 0. If you take second term outside, automatically it becomes second term as a first term as a 0. Got it? If you take the first term outside, then 1 comma 0. If you take the second term, it becomes 0 comma 1. So every element can be expressed in terms of standard basis format. So this is the important idea. So this x comma y can be expressed as x into 1 comma 0 plus y into 0 comma 1. So any element can be expressed in terms of standard basis. Then we see first subdivision we have to find T. What is T is nothing but you have to take the T on both sides. So T of x comma y equal to, just take T of x into 1 comma 0 plus T of y into 0 comma 1. Just take the variable outside. So x into T of 1 comma 0 plus y into T of 0 comma 1. So this is the main condition T of x comma y. You just label this as equation number 1. So this is the main condition. So we have to find T of x comma y is nothing but x into T of 1 comma 0 plus y into T of 0 comma 1. So our aim is to find what is T of 1 comma 0 and what is T of 0 comma 1 using the given data, T of 1 comma 1 data and T of 2 comma 3 data. So our ultimate aim is to find what is T of 1 comma 0 and T of 0 comma 1. So for that, the data is given, some of the basic data is given. What data is given is given T of 1 comma 1 as 1 0 2. So this is the data is given in your question. So I already told, so any ordered pair can be written in terms of standard basis, same thing. So just consider the vector space of the domain part. So 1 comma 1. This 1 comma 1 can be expressed in terms of the standard basis by taking first term outside and second term outside. That's all, simple logic. So if you take 1, that 1 as remain as 1, remaining term as a 0. If you take second term 1 outside, it becomes 0 comma 1. If you take the first term, it becomes 1 comma 0. If you take the second term, it becomes 0 comma 1. Now applying t on both sides. So t of 1 comma 1 is nothing but 1 into t is t of 1 comma 0 plus 1 into t is t of 0 comma 1. So now you already know the data. What is this t of 1 comma 1 is given in your question as t of 1 comma 1 as 1 comma 0 comma 2. So you can substitute instead of t of 1 comma 1 as 1 comma 0 comma 2 is nothing but t of 1 comma 0 plus t of 0 comma 1. You can label this as equation number 2. Have you understand the concept? So t of 1 comma 1 is given already. So 1 comma 0 comma 2 equal to the expression. So you have got one expression from the given data t of 1 comma 1. Similarly, we have to find the another value. So what is the another value is? So next given. What is the next value? T of 2 comma 3 is 1 comma minus 1 comma 4. So this is the another expression is given in your question, same concept. So in the domain part, what is the domain part? 2 comma 3. 2 comma 3 can be expressed in terms of standard basis by. So just take 2 outside. First term if you take now, what is the value will be? 1 comma 0. If you take the second term, what value will be? 0 comma 1. So if you take the first term, 1 comma 0. If you take the second term, it becomes 0 comma 1. So any element can be expressed in terms of standard basis. So applying t on both sides. So t of 2 comma 3 is nothing but 2 into t of 1 comma 0 plus 3 into t of 0 comma 1. So you have already know the data. What is t of 2 comma 3? So t of 2 comma 3 is given in a question as 1 comma minus 1 comma 4 equal to 2 times t of 1 comma 0 plus 3 times t of 0 comma 1. This is equation number 3. So we have find out two expressions. So given question is t of 1 comma 1 as a one value, t of 2 comma 3 as another value. So from the first value we got the one expression, second equation. From the another given value you got the another expression, third equation. So if we solve that second equation and third equation, we can able to find what is t of 1 comma 0 and what is t of 0 comma 1. So next we are going to solve the equation number 2, 1, 3. So I am just writing the second equation. What is your second equation is? So t of 1 comma 0 plus t of 0 comma 1 as 1 comma 0 comma 2. This is your second expression. What is the third expression is? So third expression is 2 times t of 1 comma 0 plus 3 times t of 0 comma 1 equal to 1 comma minus 1 comma 4. You have to solve this equation using similarly we how to solve the two types of equation, just eliminating one variable and we get the another variable. Same process we are going to done here. So just we are going to eliminate any one of the value. Just see here coefficient is 2 and not a coefficient is 1. So just multiply the second equation by 2. So second equation is multiplied by 2. What answer you got? So 2 times t of 1 comma 0 plus 2 times t of, just multiply 2 throughout the equation. So 2 times t of 1 comma 0 plus 2 times t of 0 comma 1 and just multiply 2 inside each term. So 2 comma 0 comma 4. So this is the expression derived from the second equation. Similarly, just substitute the third equation as it is. So 2 times t of 1 comma 0, 3 times t of 0 comma 1 is nothing but 1 minus 1 4. Just solve this equation. What you got? So just minus minus. So automatically the first term will be cancelled because plus 2 and minus 2 will be getting cancelled, and plus 2 minus 3 you get minus 1. T of 0 comma 1 is nothing but you have to subtract the each term. So first term minus first term, so 2 minus 1 1, 0 minus of minus is plus 1, so 1, 4 minus 4 is 0. So this is T of 0 comma 1, but here minus you have to bring to the another side. So what is T of 0 comma 1 will be, just multiply minus on both that side. So minus 1 minus 1 0. So this is the value we get from the expression 2 1 3. So T of 0 comma 1 is nothing but minus 1 minus 1 0. Similarly, we have to find the another value. What is the another value expression will be? So just substitute this T of 0 comma 1 in any one of the equations. So we arrived the value T of 0 comma 1. Just substitute this T of 0 comma 1 in any one of the expression. So better you can substitute in second equation. So what is your second equation will be? So T of 1 comma 0 plus T of 0 comma 1 is nothing but 1 comma 0 comma 2. So just substitute the T of 0 comma 1 value in this expression. So we get T of 1 comma 0. So T of 0 comma 1 is minus 1 minus 1 0. So just substitute T of 0 comma 1 as minus 1 minus 1 0 equal to 1 comma 0 comma 2. We have to find out what is T of 1 comma 0. Just bring to the another side. So T of 1 comma 0 is nothing but already 1 comma 0 comma 2 is present. So plus value brings to that side is become minus 1 minus 1 0. So what is T of 0 1 comma 0 will be first term minus first term. So 1 minus of minus is plus. So 1 plus 1 will be 2. 0 minus of minus is plus. So 0 plus 1 1. 2 minus 0 is 2. So this is the value we will get from the expression of 2 1 3 as T of 1 comma 0 as 2 comma 1 comma 2. So this is the expression we find out from the equation number 2 and 3. So why we find out this T of 0 comma 1 and 1 comma 0? To substitute in equation number 1. So we have to substitute the value T of 0 comma 1 and 1 comma 0 in equation number 1. We will find the final value. So that is the main important function we have to find out. So we have arrived the value of T of 0 comma 1 and T of 1 comma 0. Just substitute this both value in equation number 1. So first equation is T of x comma y is nothing but, see, x. What is T of 1 comma 0? Just substitute the value. So x of 2 comma 1 comma 2 plus y of, just substitute the T of 0 comma 1 value as minus 1 minus 1 0. So this is the value we are attained from the both expression. So just multiply x. So 2x x 2x plus just multiply y inside minus y 0. So how to add the triplets of the value? So first term, second term, corresponding third term. So just add the first corresponding term is 2x minus y, and second term x minus y, and third term 2x. So this is the final expression of T of x comma y comma z. This is the transformation of one vector space to another vector space. Is the general transformation of the given question. T of x comma y is, see, this x comma y, it belongs to the vector space V, that is R square, and the image of the R square is R cube. It's a triplets. So 3 values attained. So this is the general value of the transformation T. Then what is the second subdivision? Just find out what is 2 comma 3 or 2 comma, already we have discussed. So 2 comma 0, just this is the value, you can put any values. So you can substitute x as 2, y as 0. What value will be? So x value is 2, 2 2s are 4, comma y value is 0. X value is 2 and 2 2s are 4. So this is the value. So you can put any value of x comma y, you can attain the new value using this expression. So this is the second subdivision. What is the third subdivision is we have to find the rank T. So how to find the rank? So before entering into the rank, we have to know what is the dimension theorem. Rank plus nullity equal to dim v, because we can easily able to find out the nullity. Using nullity, you can able to find the rank, because we cannot directly find out the rank easily. So using nullity value, you can easily find out the rank. So by dimension theorem, rank plus nullity equal to dim v. This is the dimension theorem formula. So using this formula, we are going to able to find out the rank. So for that, how to find nullity? So nullity is nothing but dim of what? Dim of n of t. Very good. Dim, a dimension of the null space. What is null space? T of, the image is 0. So what is the image of the function is t of x comma y. So in general, we are said that what is nullity? N of t is nothing but u belongs to v such that t of u equal to 0. This is the nullity definition. See, taking one element from the domain, if you take the image of the t of u is mapped to the element 0. Here is the general form. Here what is the domain is r square. So in r square general format is x comma y. So just rearrange the formula as t of x comma y equal to 0. Why I am writing like this now? See, this u is nothing but domain portion. Here domain portion is r square. So x comma y equal to mapped to the value 0. Now my question is, see, this value is belongs to the domain part. The resultant should be in the form of codomain. So what is the codomain is r cube. So you can express the 0 in form of r cube, triplets form. That is t of x comma y is nothing but, so the 0 can be expressed in terms of r cube, other triplets form as 0 comma 0 comma 0. This is a way, because the domain is r square and codomain is r cube. So now what is the t of x comma y expression is? Already we find out 2x minus y, x minus y, 2x is should be equated to 0 0 0. Once again I repeat, we have find out t of x comma y. The expression is 2x minus y, x minus y, 2x equal to 0 0 0. So now the expression is both the equal sides. Equal sides, now what you have to do? You can compare the first, second, third simultaneously. So we are just find out the nullity as the t of x comma y original expression is compared with the 0. How to compare? So nothing but first term with first term, second term with second term, third term with third term. Got it? So you have to simplify this. So you can directly write 2x equal to 0. Now what is x value is? 0. So you can find out directly as x value is 0. If you substitute x value is 0 in any one of the equation, what do you get the y value? So if you substitute x value is 0, what happens to y? It is also the 0. Now what is the meaning of it is 0 comma 0 is the origin. So it is nothing but 0 comma 0. So dimension of n of t is nothing but nullity. So you can say nullity. So there is no points in the graph. So nullity is 0. So the nullity is 0. Just substitute nullity in 0 in the dimension theorem. So rank, what is the dimension theorem is? Rank plus nullity equal to dim v. Substitute the nullity value as 0, then rank t plus 0 equal to dim v. B is the vector space, domain vector space. What is the domain vector space? Is R square. So next line, rank T plus 0 is rank T. What is the dimension of the R square? The power value. So 2. So dimension are the any value can R square value is any ordered pair. So dimension of ordered pair is 2. So you can easily find out the rank value is 2 using the nullity concept. So this is the next subdivision. And what is the next subdivision? We have to check T is 1 to 1. So how to check the linear transformation T is 1 to 1? That is one important results we have already discussed. So we have to put in the double quotes. If T is 1 to 1, you can say if and only if nullity equal to 0. If the nullity value is 0, then you can say directly the T is 1 to 1. See, in our question, what is the nullity is 0. So you can express directly here nullity equal to 0. You can say the linear transformation T is 1 to 1. So using the single quote, you can directly say the T is 1 to 1. So next subdivision is over. What is another subdivision is? So nullity is 0 is T is 1 to 1. What is the next subdivision? You have to check T is on to. How to check T is on to? Already we discuss about the note number 2. According to note number 2, when you say T is 1 to 1, so we know that T is on to if, what is the formula? Rank equal to dim W. So this is very, very important notion. So rank is nothing but dimension of the codomain vector space, the another vector space W, not V, it's a W. So you have to be very careful writing this onto function. So you have already know. So the formula is rank T equal to dim W. If both are same, you can say directly T as onto. So what is the rank T? Is already find rank T as 2. Just substitute 2 equal to dim. What is the vector space of W? I have already told. So the question is T from R square to R cube. This is a domain and this is a codomain. We have to choose the codomain vector space R cube. So dimension R cube. So 2. What is the dimension of R cube? It's a order triplets. So what is the value is 3. So 2 is not equal to 3. If 2 is not equal to 3, you can say T is not on 2. Because if the both values are same, rank and dimension W are equal, you can say T is on 2. But in this case, rank is 2 and dimension W is 3, which is 2 not equal to 3. Therefore, T is not on 2. So this is a very important concept in linear transformation. So just recall the linear transformation. So number 1, linear transformation, the T of alpha u plus beta v equal to alpha into T of u plus beta into T of v. This is the main condition you have to be satisfied. If T is linear, there are some of the parameters you have to know. Number 1 is rank and number 2 is nullity. Using rank and nullity, there is one theorem is called dimension theorem. Rank plus nullity equal to dimension v. So using the concept of this, we have attained all the parameters. So this is very, very important concept in linear transformation. Vector space, one vector space to another vector space. Thank you.